This is a video for the paper called Hindsight Credit Assignment. The question that credit assignment asks is, how did my past actions influence the future outcomes? The way that the reinforcement learning agent usually goes about this question is by relying on the MDP structure of the world, and in particular by taking time as being the main proxy for credit relevance. For example, here we have credit assignment in RL, or Carl, who looks at the weather forecast in the morning and has to decide whether or not to take an umbrella to work. Carl decides not to take the umbrella, goes to work, and it ends up raining. Now Carl has to figure out what it was in his day that made this happen. Because Carl is an RL algorithm, he goes through his day in the backward chronological order until eventually, after many trials and iterations, he figures out that in fact it was the umbrella. Now, what we would like to happen instead is for the credit to be moved directly from the rain to the umbrella. So the key intuition that we propose in this paper is to, instead of relying on the standard MDP assumptions, to explicitly learn the credit relevance structure. In particular, we consider the probability of a past action given the state that it was taken and some form of the future outcome, which is measured as a function of the future trajectory that starts from that state and action. In particular, in this paper, we take this function to be a future state or a future return. And it turns out that this is not just a heuristic, and that we can actually rewrite our usual value functions in these terms. In particular, now, in the usual discounted sum, we can additionally weight each reward by this probability ratio of the probability of the action whose value we're estimating that is conditioned on reaching the state that is giving us the reward, divided by the probability of just taking that action. And this ratio explicitly measures how relevant was the past action in achieving the state and consequently the reward. So in the family of HCA algorithms, we propose to learn an estimate for this probability P and then use it to sample this expectation and follow the policy gradients accordingly. We devise a set of diagnostic tasks that illustrate the issues with standard credit assignment in RL and show that HCA is able to tackle them. For the complete details, please read the paper.